Good morning, everybody. DIYDave is back at it again. We've got another project. Today we're going to be installing this space heater in my garage. Here in Oklahoma, we don't have exceptionally harsh winters, but when it does get cold, it gets really uncomfortable here in my garage, and especially when it's too cold to work outside. Been wanting to do this for a while, and we're finally getting the opportunity to do it. So we'll hope you'll join us and hope you enjoy the video. If you haven't already, please subscribe to our channel, hit the notification bell when we do these DIY videos so you'll get notified and enjoy the DIY fun with the rest of us. Thanks for joining and hope you enjoy the video. When it comes to making a choice for a space heater in a garage, you've got two choices. You'd be either a gas-fueled unit or an electric-powered unit. Now, a gas unit is going to involve an open flame. You're burning propane or natural gas. Well, since this is my garage and I've got, gasoline and oils and a lot of petroleum things relating to you working on cars, I didn't want anything to do with an open flame unit. So that eliminated that option. So I pretty quickly went to an electric unit. Now, an electric unit, you have fairly readily available plug-in heaters that you can get that plug into a 110 volt outlet. The only problem is those just don't have the power necessary to do an appreciable change to the temperature in your garage. So that immediately led me down the path of one of these 240 volt units. This particular unit is 7,500 watts. I looked at the 5,000 watt unit. And I just didn't think they were going to have the power to do the job that I wanted to do, and I thought the 10,000 watt was probably overkill. When I built this house, I made sure that the builder insulated the garage walls. A lot of builders won't do that. Well, it's a garage. Why do you have to have it insulated? Well, I wanted it insulated, so hopefully that will help keep some of this heat in. The garage door that I had installed when we built this house, this is an insulated garage door. And even though this is a 3-car garage, I'm really only mostly concerned with keeping this main 2-car area heated, and that's why we're going to mount this unit in the corner of the garage over there. Now, the other part of this is because this is a 240 volt unit, what we're going to have to do is run a 240 volt line, a dedicated 240 volt line from the outlet box over there to a ceiling unit somewhere, a ceiling outlet somewhere in that general neck of the woods, and then we will connect that to the heater. So we've got a few things to do, got a little bit of homework to do. So in terms of the rating, in general, from what I could tell, a 10 by 10 foot space, assuming an 8 foot high ceiling, a 5,000 watt unit is generally considered adequate. This is a little bit larger. I figured a 7,500 watt unit would be just right, especially considering that the garage is insulated. So before we jump in and start doing the work to put in the wiring for the 240 volt outlet, we've got to do a little homework to determine the right kind of wire, the right kind of breaker, and the right kind of material that we need to do the installation. So let's go to the whiteboard of knowledge and do a little math. So as we plan the circuit that we will use to power this 240 volt heater, we've got a couple of important things to consider. Number one is the size of wire, or the gauge as listed in American wire gauge units. The bigger the diameter of the wire, the smaller the gauge number and the more current it can carry. The second thing that we have to consider is the size of the breaker. Breakers are rated to carry a certain amount of current at certain voltages, and you have to get a breaker that is generally the actual load on it is not more than 80% of its rated capacity. Fortunately, these two things are fairly easy to determine. Pretty simple equation in electricity is that power is equal to the voltage times the current. And that is just, we can rewrite that for simplicity as P equals EA. Well, it just so happens that we know that the power for for our heater is 7,500 watts. And we also know that our voltage source is 240 volts. What we don't know is the current. Well, that's just algebra. We can rewrite this equation as current equals power divided by voltage, or in this case, we will show the amperage is equal to 7,500 watts divided by 240 volts. And we do a little arithmetic and we find out that that current is 31.25 amps. So, how does that help us determine what gauge of wire that we need? Well, we turn to this handy dandy little sheet that I had downloaded off the internet, and there are numerous places where you can find this kind of information. But what we find out is what we're going to be using is called non-metal shielded wire. It's just a wire with a sheathing. It's not a metallic sheathing. It's a coated wire. In fact, we'll have two conductor wire, and it's called NM-B, which is standard residential house wiring. So if we look on this chart, we see here is NM-B wire. And we look down here for the first number that is greater than our rating. This is the amperage rating. So if we look down this number, we'll see here is 30 amps, which is below what we need. But here's 40 amps, which is above what we need. We need a wire that is rated to carry more than we will need. So that means that we need to go to the 40 amp selection, and that takes us back here to the gauge column, which says we need 8 gauge wire. So that solves that first problem. We need 8 gauge wire. So that's problem number 1 solved. So what's the second problem? The breaker size. In general, the rule of thumb is that your load shouldn't exceed 80% of a breaker's rating. That means that your breaker should be rated for more, substantially more than what you're actually going to pull. Well, we know that our load is now going to be 31.25 amps. And if that number shouldn't be more than 80% of our rated load, we can divide that number by 0.8. That gives us a rating value of about 39 amps. So that means that our breaker should be no less than 39 amps. Well, they don't sell breakers in that weird units. They usually sell them in multiples of 10, I guess maybe 5, but usually 10. So that means that what we will do is we will find us a 40 amp breaker. So we now know that we need 8 gauge wire and we need a breaker that's suitable for delivering 40 amps. So what's one other piece? It's not really a mathematical calculation as much as it is an understanding of how you get 240 volts to a breaker, out of a breaker. Most of the service to most residential houses, at least in the U.S., is 240 volt service, but it's delivered in 2 phases. If you look at AC electricity, if you looked at it on a scope, it's called alternating current because it alternates like that. And you have 2 different phases coming into the house. And if you looked at one phase, it would look like this. But then if you looked at the other phase, it would be exactly opposite. And I'm drawing this very poorly, but it illustrates the point. It's exactly the opposite of the other phase. So if we tie 2 of these together on what we would call 2 different poles of service with a 240 volt breaker, a breaker designed to handle both phases at once, we get 240 volts. We capture each one of these out of phase, so we have both phases going into one breaker, and they end up delivering the current that we need and delivering at 240 volts. So what that means is that we need what's called a double pole breaker. And that's simply one that can tie into both phases of electricity from your service box at the same time. So, in summary, we need 8 gauge wire, a 40 amp breaker, and that breaker needs to be double poled.
I'm slightly off screen. But that's what we need. Hope that explanation makes sense. So let's go back, inventory our parts, and get ready to run the wire.
Well, after that little summary about how to determine the proper gauge of wire that is required to sustain your 240 volt connection, thought I'd go over the equipment that I bought to put together this connection for my heater. We've got a 25-foot length of 8-2 wire. Again, that is 8 gauge, 2 conductors with the ground. Having a new gang work box. It's a little bit larger than I really need, but it's got plenty of 3/4 inch knockouts. And I've got a cable clamp here that will go in the side, and this will go in the ceiling. This end of the cable will go through this with the cable clamp secured to it. These guys right here are adapters that will go into the inside of my breaker box, but then serve as a clamp for the wire when I pull it through. The way my circuit breaker box is installed in the wall, it's actually prevents direct access to the sides of the box. It's flush into the wall. So I don't have any access to the outside when I hit the knockouts and secure a clamp from the outside. This is a special kind of connector that is made by Arlington Company. This is the Arlington NM95X. And what this lets me do is when I have the knockout on the inside of the breaker box, I can slide this in, pull the cable through, and it will serve as a clamp, and then it will lock it in place as if I had a clamp on the outside. I had to order these from supplyhouse.com. No local vendor, none of the big box places, and even none of the local electrical supply retailers had this in stock. This is just a nice fresh pair of wire strippers that can do 8 gauge. You can actually do several gauge wire, but I wanted to have a good stripping tool. And we have a 40 amp double pole 240 volt breaker. One thing to keep in mind is I had to make sure that I got the proper kind of breaker for my breaker box. Different breaker boxes have different requirements. This is a type CH breaker. Basically, it'll amount to stripping the wire to length, putting it inside these cable clamps, these wire clamps, and then snapping it into place. And we'll go over that when we get to that point. Now, here's the part for the other end. Now, the heater that I have purchased is intended to be set up for direct hardwire. I've decided I don't want to do that. I'm going to modify that a little bit. What I'm going to do is I'm going to adapt it and give it such that it has an external 240 volt plug. There are a couple of different ways you could do this. There are conventional adapters. I just got what's essentially rated as a range cord. It looks a little different. Have a four-prong 240 volt adapter for the outlet, and then a cover plate for the box. This will simply go in here. That will go in there, and the cover plate will go across all of it. And then this will plug into it, and I intend to hook this to the power side going into the heater. This may be overkill. There are other solutions that will accomplish the same thing, and I know this says it's for a range. I don't really care what the label says in terms of whether it's for a range or a dryer. I care about its rating. This is rated for 50 amps. This is way more than I need for the 31 amp load that we've calculated for our garage heater. Conduit, breaker, cable clamps, strippers, connectors, outlet that will go into the box. That's all the equipment we need. So all we need to do now is run the cable and wire up the outlet. One additional piece of equipment that I'm going to use for this are these non-conductive fiberglass, they call them fishing sticks or fishing rods. These are flexible sticks that will allow me to run through the knockout that I will punch in the circuit breaker box, go up the side of the wall, and then go up into the attic, tie the cable to, or tape the cable to the stick, and then pull it back down. So the first thing we're going to do is we're going to take this panel off, take the cover for the panel off. We're going to take a knockout out of the panel here, and then we're going to run one of these fish sticks through the line up into the roof, or into the attic, and then I'll go into the attic, take the cord, the cable that I've already put up there, pre-positioned it up there, and I will tape it to the stick, come back down here, and then pull it through, and then hook up the new breaker. Not terribly complicated. We're going to go ahead, take this panel off, We will cut the main power to the house. We'll be in the dark, so I've got some backup light available here. I'm trying to avoid opening the garage door for natural light because my house faces to the north. I don't get any natural sunlight in, so all it's going to do is make the garage colder, and it's already about 51 degrees in here, which is a little bit chilly even with this jacket that I'm wearing. So we're going to turn on the back light. The light may not be the best, but we will do the best we can to show what we're doing as we do it. So with that, let's get on with it. So here goes the big raker, turning off power to the house right now. There, the house is dark. Now, one thing that's very important to point out, I'm going to bring the camera over here just a little bit. We turn the power off, which means that, roughly speaking, everything above this breaker is dead. But here's something that's very important to understand. These two cables right here are the main supply voltage from our electric service provider. These are still hot. You cannot turn those off. So we want to avoid touching anything down here. Just plain and simple, we don't want to touch anything down here. When we run the cable that comes in from the roof, we're going to run a ground line into this bar over here somewhere, and then we will run what will be a black and white wire into the breaker that we'll plug in probably right about there. We're going to take that knockout. There's a knockout right there. Can't really see it because of the light, but there's a knockout right there. We're going to open that guy up, and that's where we're going to run our cable. Okay, I was able to use a screwdriver to knock out the hole. Let me move my camera just a little bit. I was able to use the knockout, but I have encountered two problems that we're going to have to overcome. First, the knockout is a little bit smaller than I expected. For 8.2 NM cable, you need a 3/4 inch opening. That's what this adapter lets me do. This adapter acts as a clamp inside the box. So once the cable is run, the cable fits against these teeth and it keeps the cable in place. Well, this fitting right here, the outside diameter is 1 inch. So I need to increase the size of that opening to 1 inch. Now I've got a step drill bit to do that. So I'm going to put on some safety glasses and expand that opening. The second problem that I did not expect is that I found out that this section of wall immediately above this outlet is insulated. That's going to could make fishing the wire from the attic a little bit more difficult. Just have to see. Okay, it's been a few minutes and I have wrestled infinitely more than I ever expected using my step drill bit to open up that hole to receive my fitting. I think I finally got it there. The bit that holds the little clamps that hold the bit in my drill just don't hold it tight enough. My other option is to go to an electric drill, but to use an electric drill, I'd have to turn on the power, and I don't want to do that with the panel exposed. I think I've got it close enough. I think we're to the next point where I can try to fish that wire through the attic and get the wire that's up there to fish it back down through. We're just going to have to see if I can get it past the insulation that's immediately above this. And quite frankly, I don't know. I really don't. So I'm going to take a couple of these. And the genius of these is that they are threaded. See if you can see that, but these, focus please. Yeah, these ends are threaded so you can hook two of them together and fish them through the wall. Quite ingenious. Here goes nothing. I'm hitting something hard already. And you know what? I bet you I'm hitting the top plate of the wall. That's got to be the top plate. Okay. So what I'm going to do, I'm going to go upstairs earlier than I expected, and we will regroup, go up there, and see if I can figure out where this cable sits. So we're off to the attic. So this is the first time I have used this, what we call an action cam. It's not a GoPro, it's from a company called Acaso. It was a Christmas gift from my kids. So I had not planned to film up here because I didn't want to bring my tripod and there's too many other things going on. But what we can at least see, and I hope you can see, is here's the cable, and that's where we were fishing. And I'm going to have to figure out a way to reach around there to see if I can feel where that wire is coming up. And if I can't, our project's in trouble. So we're going to set this light right here. Cisco! Ha! Okay, we've got our fish wire, but something is jamming it. What is snagging it? Okay, let's go back downstairs. It may not matter. I don't have to have a whole long length up here to tie up to. All I've got to do is be able to tie it and then pull it back down. Okay, we had some success in the attic. So if you've seen that part, you'll know something got us stuck. We've dug around the wall and found the fish wire and then pulled it up. Something snagged us, and I thought it was probably this metal fitting where the two pieces connect. So sure enough, it is. So I'm just going to push that up. It's straight through. Now all I got to go do is go back upstairs, tape together the wire, and see if I can pull it back down through. See what it looks like. Probably over taping this, but that's okay. Okay, so now we'll just see if we can push this back down the hole or pull it back down the other direction. Take your pick. I was able to get the fish line up in the attic. I wrapped it with some electrical tape to the conduit that we're running down here, and now I'm going to pull it back through. At least that's the plan. So let's see. We're through! Well, what I'm going to do now is I'm just going to untape my line right here, put in my fitting, and we'll go ahead and wire it breaker. Okay, a little bit of updated information. I have separated the fish wire from the tape, so we now have our NMB wire from the attic. I was able to slide the connector fitting onto the wire and lock it into place. Let me see if you can see that. So that's now locked into place, nice and secure with that cable clamp. So literally all that we have to do now is trim enough wire to feed a breaker that we'll put there, and then the ground wire that we will plug into that available spot on our ground bar. The next step is I'm going to take just your utility knife, and we're going to split the sheathing on this cable so we can get to the separate conductors for the wire to hook up the breaker and the ground. There we go. There we go. There. Here is our ground wire. We'll just take the paper coating off of it. And I'll okay. We're aiming for this conductor, and we're aiming for that ground post, and then these two wires will be hot, and they will go into the studs for the breaker that we'll plug in here. And what we'll also do is take a little bit of red tape to indicate that this white wire is actually live, because ordinarily white wires indicate neutral. And now we will go get our breaker and plug it in. Here's our double pole breaker. We showed that in the inventory. Now what we want to do is make sure that we install this in the default off position. That way, once we get it wired up and ready to go, we can put the panel back and turn the power to the house back on, but leave this off while we wire the actual power plug for the heater. So if you'll, it's a little, make sure that you can see it, but we are in the off position. That's on, that's off, so we can plug this guy in. Now the way this works is there are these tangs. These tangs fit over the outside edge of the breaker panel right here. We fit them across and then lock it in. So it's off. Let's go ahead and do that. There. So now we just need to get our cutters, cut this to length and strip off about 1/2 inch to go into these studs here. And we'll be in good shape. About here. Okay. Now we're going to use the 8-gauge measure to strip off about 1/2 inch of wire. There's that. And then here's another 8-gauge, about 1/2 inch. There. Going to get this red tape, and we're just going to mark off a conspicuous length to show that this is hot. In general. So I'm going to quite arbitrarily put there we go. And this is all in.
We have our fitting. We have our NMB wire coming up from the attic. We have it routed down to our breaker. We have one leg on this pole. We have the white leg with some red tape to indicate it's hot. On the other pole, it is secured and locked in nice and tight, good and snug. The breaker itself is off. We have the ground wire, have it running in behind these other wires, and we have it tied into that ground bar, and we don't have a neutral. So I personally think we have done all of the relevant checks. I think this part of the wiring is done. So I am going to put the cover back on and turn the power back on in the house. We need to knock out these two, can't see with the frame. We need to knock out these two guys where our new breaker panel is. There's one. So, hopefully nothing will explode. There's our new breaker. Here it goes. Now we can focus on wiring up the outlet to actually power the heater. Okay, hello everybody. We are now in the attic with our cable all installed and our breaker installed. All we really have to do now is install the outlet. I had originally located the idea of where I wanted to put the box right here, but decided I wanted to go over one more section. So I'm trying to keep the angle somewhat sane here. There should be plenty of light. So here is the box we're going to use. And I want to install it right there. We'll just draw a line on that side and that side, and that gives me a template to cut through with my keyhole saw. We're going to cut this guy. So now, all we've got to do is take that box and fasten it with some nails or screws on the inside. We have screw holes right here. You can get in the camera. We have screw holes right here, or nail holes. I'll just nail those into the studs from below, and we'll be in business. Okay. Here's our outlet, so all we've got to do now is secure that to the stud that's on this side, and we'll be in business. Okay, I hopefully have given you a better camera angle. All we've got to do is run the, and I can't see them, I'm kind of filming this blind with my phone. All we've got to do is pick one of the knockouts here, put the cable on a cable clamp through, secure it, and we will be done up here. So, hopefully you can see this, but that's the cable clamp we're going to put. That's the cable clamp we're going to put through. Just have to pick an appropriate size knockout to run the hole through, and we'll be in business. Order hammer, or hammer with there we go. I'll just take the cable here, make sure this clamp is loose. There we go. And then we will now I think what I'm going to go do, I'm going to go take this ring. I'm not going to bother to take the whole camera back down there. I'm going to take this ring and just fasten that on the inside to secure this. And then I'll come back up here and clamp down that cable clamp. Okay. Like I said when I was up above, I'm just taking this cable clamp on the nut on the cable clamp. I'm going to affix it on this side so we can secure that clamp on this side, and then I'll go tighten it above. So I'm going up and down the stairs. Tactical error. I should have clamped down the cable so I could pull the cable with the clamp into the hole and secure the nut. So bear with me. There's that clamped. And there's that screw tight. There, much better. There, we're clamped. Come on. Yay. We are in. Whoopie-doody. All that's left is to trim that wire and actually install the outlet itself. Okay. Okay, we are now done in the attic. All we have left to do now is to cut this amount of the wire to length and then wire up the outlet. And we want to make sure this wire extends 8 inches beyond the box. Right there. Just double check that. That is to right about there. There we go. There we go. Oh, I just punched myself in the nose. That's a neat trick. I literally did just punch myself in the nose. Oh my goodness. Okay, so there's our ground wire and our 2 hot wires, and I think for the sake of accuracy we should probably go ahead and wrap some red tape on this white wire to show that it's not a neutral. Here is the outlet that we're going to use. It's a 4-prong outlet, has a green lug to indicate the ground, has 2 colored lugs, non-green to indicate the loads, the live loads, and then this one to indicate the neutral. So all we're really going to do is loosen the lugs for the ground and the 2 loads, and we'll leave the neutral unconnected. I'm going to wrap a little red tape around this guy to show that it is live. And we will proceed accordingly. There's that. Hope you could see any of that, not just my fat head. I'm sorry if that's the case. We will now bend this wire. Okay, it is in, it is secured. The trim work on the sheetrock is not the best, but it is not a cosmetic project. It's in, it is secured with the proper screws, and all that we like now is testing it and plugging in the heater. You would not believe the minor ordeal I went through with those little tiny screws and my meat nugget fingers, starting a screw, dropping the screw, starting the screw, dropping the screw, starting the screw, dropping the screw, and then crawling all over the garage floor looking for them. I'll bet you if I did it once, I did it 10 times. Arguably, the simplest part of the project that was the most tedious and most annoying and most prone to making me want to throw my screwdriver through a wall. But it's in. We're getting ready to put the actual ceiling, the heater in the ceiling. Those marks there are where I believe a stud is located. The instructions for the heater say to put it not closer than 13 inches to the wall, but since I intend to put this in such a manner that I can turn it slightly, I want to make the extreme distance equal to half the diameter. In case I turn it, I want the closest point, if I turn it, to be at least 13 inches away. So that means I put a mark 21 inches away, and I'm going to put in a test nail at that location right there, just to make sure I'm really on a stud. And if I am, I'm going to drill a pilot hole and then put in a lag bolt with 2 washers on it. That's the frame, that's the stud. It's 20.5 inches. I wanted 21, but we're already beyond the location where they wanted. So I'm going to go ahead and drill the pilot hole and get the hanger mount. My drill may be giving out on me, folks. Now, so here is the bracket from which the heater will hang. Going to put one washer on the top, one washer on the bottom, and this is going to go in the hole I just drilled. That should be big and bad enough into a big hairy stud to hold that thing. The heater's not that heavy. So we found the 19mm impact socket for the bolt, and we are prepared to install into the roof. Here is the actual heater out of the box. Pretty basic unit. This one does not have a digital control. It has 2 power settings, a minimum and maximum. Just a power button and then a low-high switch with a fan in the back. It's decently built. I'm probably not going to set any records. I saw several slight variations on this same construction from different sites. I have a feeling that the bulk of them come off of a very similar Chinese assembly line somewhere. I did not see there were some control differences, and the color of the case was a little different, but the basic operation is pretty much the same, I think. So what I've got to do now is figure out a way to get this thing up the ladder, or my step stool, and attach to that brace so I can get it secured. And that's going to be a challenge because I have no help.
Okay, I eventually had to enlist the assistance of my nice tall son, who was kind enough to come up and hold that thing in place while we got the bolts and the knob screwed into the side. So it is completely mounted. All we have to do now is install the power cord and our power plug over there, and we can test this thing and see if it's going to work. Okay, I had to break from filming because the area in here is so cramped that it's almost impossible to really get a good angle. So let me tell you what I did. I took the long range cord that I had, which had essentially little banjo clips on the ends, and for the two power cords, I chose to use the red and the black. I then took the white, which would have been neutral, and I'm not using it, and I'll tape it off here shortly. I then connected the green to the ground on the bottom of the heater. I took the raw cord, the wire, and put it into the two terminal plugs on the little terminal block here, and that should provide both legs of power. So really, all that's left to do now is to plug the cord in, turn the power on, and see if the thing works. So we're going to go over here, plug this guy in. Let's plug it in. Going to leave that open for just a moment. Now we're going to turn on the breaker. Moment of truth. Folks, it's working. It's really nice. I've got it maxed out on the high right now. Power is on. It's working. We'll run a little test to see how it's going right now. My little garage thermometer says it is 56. The time on that clock is not right. It's really closer to 7:30. But what I'll do is I'll leave that thing running for, say, a half an hour and see if this makes an appreciable difference in the temperature in here. Well, we're doing a 30-minute check on the heater. It seems to be running just fine, and we have already increased the temperature 2 degrees. And keep in mind that thermometer is on the floor, and since heat rises, it's going to warm up the upper part of the garage space more quickly than the floor, and it's already raised the floor temperature 2 degrees. It already feels really nice out here. In the half an hour that it's been running. So I think this has been a complete success. It took a little longer than I expected. I didn't expect to need the help of my son, who came by to help me lift that into position. But that thing, I'm standing 6-7 feet away from it. It's putting out really, really nice, steady stream of hot air. And it's pretty good at self-regulating, because I can tell that even though I've got the thermostat on high, the little heating elements are not on at the moment. So it's the little internal thermostat is cooking. It's working great. I don't see any signs of any issues. I don't see any flame or smoke or anything, no sparks. So I think our electrical is good. I think this has been a complete success. I'm tickled to death. I have been wanting to do this. I bought this heater over at Northern Tool. I bought it over a month ago, and I keep getting overcome by events where I couldn't get it done. Finally, this is, we're supposed to have ice and snow later this week. If I didn't get it done this week, it was going to be at least 2 more weeks. And I wanted to get this thing installed before the winter was over with. But this is going to be a great addition to the garage. Keep in mind, I'll close the bottom of that and screw it back up and get it all closed off. I'm just keeping it open so I can monitor for any issues in the connections. I don't expect anything, but I'll close that all up when it's said and done. So, In summary, this has been a fantastic project. It took me a little longer than I expected, had a few issues. It took me as much time fiddling with little screws and putting in the outlet and lining up the plates and getting the wires back in the gang box. It took me as much time fiddling with the little details like that as it did, you know, pulling the wire and wiring up the breaker. All of that stuff went exactly according to plan. Everything, I had very few leftover pieces, and I am totally happy. I'm really stoked with the way this has turned out. I've wanted to do this for a long time. Finally got the chance. If you like the video, please give us a thumbs up. Put your comments and concerns and questions in the comments below. I love responding to your comments. Been getting a lot of comments on the Quick Jack video. Got some, still get comments on some of my older videos, especially the ones on the Rhino ramps, which I don't use anymore, did not get anything replaced. Love to hear from all of you. I really appreciate it. If I've helped one person, I got a really nice comment from someone the other day saying that they really appreciated the video I did on the Toyota fender liner because they just didn't know how to do it. And hopefully I gave them a push in the right direction. I love to hear that kind of feedback. I thank you, each one of you who subscribe and take the time to watch. Hope you enjoyed this video. This was a big video for me. I had a lot of video to put together to assemble this, so I'm not sure how it's going to turn out until I put it together. I thank you for taking the time to watch. And remember, this is DIYDave. If it's worth doing at all, it's worth doing yourself. Thanks for watching and have a blessed day, folks. Bye-bye.